Good morning, everybody. How you doing today? There we go. Hey, thanks for joining. This is the latest in a series of streams I've been doing leading up to AWS reInvent. AWS reInvent is the end of, first week of December. We've got 18 days remaining. Kind of crazy. So we're live right now on Twitter and on LinkedIn. Fire off your comments here in LinkedIn, or you can send me a tweet as well, and I will respond to them as I can on the stream. So I wasn't on last week doing this series because I've started another series for Trend Micro called Let's Talk Cloud. That's been going really, really well. I'll show you that in 2 seconds. And also, I was at the Fast Company Innovation Festival in New York City. I was giving a talk there, and that kind of took up a bunch of my week. So apologies for not having a stream about AWS last week, but we're back at it right now. And I wanted to talk about AWS compute services because I think a lot of people assume they've got it on lock, but I think there's a lot of questions, and at least I see a lot of questions, especially when I'm talking to people who are just getting started in the AWS Cloud, about what should they be picking, what are the options, where are they, that kind of stuff. So we're going to dive into AWS compute services just like we did with AWS database services a couple weeks ago. So let me just share something on my screen for a second. So I already dropped this link in the LinkedIn chat, and you can hit it up, obviously, marken.ca. It's one of the main links there, and you see I have my ultimate guide to reInvent. So if you're coming to the show in 18 days, this link will let you know what's going on as far as activities, how to sign up for talks, all that kind of stuff. And then also I have an official guide on the AWS site. And then I'm giving 2 talks. So SEC 204 and then DOP 204. But yeah, you can see here the last one we had was databases as well as a redemption on Dynamo, right? Because I messed up that a little bit as well. So keep the questions going. But as I mentioned, Trend on the Trend Micro channel, we started this new Let's Talk Cloud series. We had an episode last week, another one yesterday. Basically, it's very casual, sort of informal. I'm talking to various folks. We're starting with people in Trend just because we're not sure about the format. We're trying to experiment a little bit. Then we're going to be expanding it out to get guests from around the community and really just kind of giving you that on the ground sort of real world experience, and it's been going really, really well. I'm actually really happy with that one. So let's get rolling here. I see Ashley's already got a question on LinkedIn, which is great. How to use AWS with a CMDB, configuration management database. That's a great question. There's a lot of stuff in that we can dive into. We'll talk about a bit about that today, but really what we want to talk about is AWS compute services. So here are some slides that I pulled together, and as always, I'll publish these afterwards for you. But keep the comments coming here in LinkedIn and on Twitter, and I'll tackle them when I can. Basically, we've got compute services breakdown, or I find they break down far more easily around what type of compute you're getting. So compute basically means making a decision. So this is where you have either code you've written or code you've gotten, and you're trying to make some sort of decision or manage the flow of information. So you're doing some sort of processing on information that you've gotten. And really, that's all programming is that you take an input, you do something to it, and you have an output. That's what the compute services are doing, right? You have some sort of input, you're doing some sort of action or transformation to it, and then you have some sort of output. And of course, there's a million different ways that actually happens. Now, the main unit of compute for most people, at least conceptually for most people, is an instance or a virtual machine. Now, all of the services you see on screen right now are instance-based, and we're going to dive into each of them a little bit, give you this sort of overview of what's going on, but sort of the classic is the Amazon Elastic Compute Cloud, or EC2. That's where you ask AWS to give you a instance, Linux or a Windows server, and you take over from there. We cover that in the shared responsibility model. But that's the core of Amazon EC2. And that is, the fundamental unit is an instance in AWS parlance. You pick how much memory, how many CPUs, graphics cards, all that kind of stuff. And in fact, we'll dive in a second and try to do that on our own. Well, not try, we're going to be successful. At least we better be successful. If we fail making an instance in EC2, then I'm going to have to stop streaming because that's just sad. I should be able to pull that off. And I'm just making sure I'm logged in on the background here. So the instance is our core piece of compute. Now, everything else on this screen is either there to support or a more specific version, sort of an additional level of management on top of that. Let me just grab my password here. This is not like letting me log in this morning, which is never a good sign. There we go. Okay, so we're logged in the background. Great. So I'll show you that in a sec. So when we've got, you'll notice Elastic Beanstalk creates an instance and a bunch of stuff around it to help you build out a web application. So in Elastic Beanstalk, it comes pre-configured with a number of, I think I pulled that up. Here, let me pull it up for you. It's far simpler just to show you guys this stuff, right? So Elastic Beanstalk helps with Java, with PHP. Let's just flip over to my browser. There we go. So you can see you've got things like Java, PHP. If we go to the FAQ, the FAQ, you'll see the development stack. So if you're building something with Apache Tomcat, with Apache HTTP, Nginx, Ruby applications, .NET applications, Java, Docker, Go, Beanstalk does a whole bunch of heavy lifting for you. It creates a database, it creates a load balancer, creates the EC2 instance. So it has taken your core of compute, your instance, and built stuff around it, right? Which is why I have it laid out on the same page as the rest of this EC2 or instance-based stuff. Same with VMware Cloud on AWS. VMware Cloud on AWS takes VMware and puts it on some solid hardware, so it's bare metal instances running in AWS, and then you have virtual machines, so not strictly instances, but virtual machines in a VMware concept, but it's the same logical unit of compute, and then you can expand out into EC2 as well. AWS Outposts is this super cool on-prem environment where what you basically get is you get a giant rack filled with native localized services. So very, very cool. I don't know if I can show you this video, the embed. Yeah, they don't actually have a picture of it, unfortunately. I wish they had a picture. That would be super cool. But essentially, it's a giant rack that runs AWS services that you can have local. So same thing. You're getting that core idea of AWS compute, of being an instance in your own data center, right? That's AWS Outposts. Batch is a way to stitch instances together to accomplish a task. So if you have a bunch of files that need to be crunched, you can do this with AWS Batch, and it configures a bunch of instances together to work as one workflow. But again, the same core as an instance. And then Lightsail is designed to run around can compete with things like DigitalOcean or HostGator. If you're running like LampStack or WordPress, it's a really low-cost single server way with a bunch of wrappers around it again. Now in the corner you'll notice Elastic Load Balancing, and then actually a mistake here with the container registry that should be on the next page. But Elastic Load Balancing helps you route things to your EC2 instance, but it's classified as a compute service. It's kind of dodgy, to be honest. If you guys have questions as we're going along this, just hit me up in the comments. Either reply on Twitter or in LinkedIn. Happy to address specific concerns. But then you might notice that ECS is here on the page. So Amazon Elastic Container Service. I'm showing on the instance page. Now, people probably going, why? Why are you doing that? That's a container service. It is, but it isn't. So it's designed to help you run containers, but you have to run the instances that host those containers, which is why it's on the instance page. Because that is the fundamental unit of compute there, is that you are running instances in order to accomplish your goal of running containers. Sounds kind of weird, but it's really important from a responsibility perspective, is that you're responsible for those instances. So if we go to the next page here, we get the next round of compute. Let's make sure that's there for you. All right. Next, we're out of compute. I pulled ECS back onto this because you are trying to run containers on ECS. AWS Fargate, which is a managed container service, and then I put the registry where it was actually supposed to be. That's where you get your containers from to run them. Then we have functions, which are serverless compute, AWS Lambda, and then we have the application repository, or SAR, as well to run those. So very different types of compute here. On the first page, it was all variants of you have a server somewhere, which is an instance in AWS parlance, and you are going to load it up, you're going to configure it, you're going to run it like any other system you have. So like my iMac, same kind of concept, it's in the cloud and it's running server-based workloads. For containers, that's something different. You get rid of the operating system and you're packaging your application up essentially like a zip file for your application, right? You've taken all the dependencies and everything you require to run your application, you put it into one package. That's a container, and we're going to try to run it. Now in ECS, you run it on your own fleet of virtual machines. In Fargate, you're running it on AWS's fleet, and you don't have to worry about the management of that fleet. You just worry about the containers themselves. Now, when you move over to Lambda, functions as a service or serverless compute, and I always say serverless compute because serverless refers to the architecture of these things, but for a function in Lambda, you're now getting rid of all that extra stuff as well, any operating dependencies and things like that, and you're just writing your code. So you've removed another level of abstraction or another level of support away, and you're getting simpler and simpler. So Lambda is far more micro sort of event driven, and you see that scales up wildly. So we've got containers and functions. So really instances, containers, and functions are our main units of compute within AWS. And if we scroll down, this is where it starts to get kind of interesting. So let's look at how, why do these matter? Why are these different? Why would you want different levels of compute? Well, it turns out the goal of the cloud is really to do less to generate more value. Right? You want to do less work, and I know I want to do less work because, that's just what it's about. Technology is supposed to really amplify our ability. It's supposed to streamline things. It's supposed to make them simpler. So with compute, you need to keep that in mind. You need to say, okay, what fits my needs? How much work do I have to do to get how much value out of this? And if we look at the start, the two sort of biggest, heaviest loads are going to be AWS Outposts and VMware Cloud on AWS. Now, that doesn't mean that's bad. What that means is you need to be aware of what you're getting for what you're spending. And spending in actual cash as well as in effort. So for AWS Outposts, if you have a data center and you want to start working in an AWS Cloud native way, Outposts is fantastic because you can leverage that data center space by putting racks of AWS equipment in essentially and leverage it there. Same with VMware Cloud on AWS. If you already have a huge VMware installation, VMware Cloud on AWS helps you leverage the same set of technologies and operational setup to move forward, but that's a lot of heavy lifting. There's a lot of parts you need to worry about here, and with AWS Outposts, there's actually physical hardware that you need to worry about. So these are concerns, right, because you're doing more work and you're not getting necessarily more value compared to that ratio, right? So the next kind of thing we move over to is the actual EC2. So spinning up an instance and getting access to something. That's EC2. Now, that is the bread and butter of most people's compute workloads on AWS, and there's nothing wrong with it. This is sort of the normal forklift method. If you have existing stuff, you move it over into EC2 because that just works, right? If you're running on Windows in your data center or in another environment, you can run it on Windows in EC2, and there's a whole bunch of benefits to that. But it's still not like super cloudy, right? You start to get more value as you move over. So something like AWS Batch. Now, if I have a whole bunch of files that I need to convert from one format to another, I can start to do that in a batch where it's going to automate spinning up instances, doing work, and then spinning them back down and completing that workflow. So now I'm starting to leverage some of the power of the AWS Cloud with this extra wrapper around EC2. And the same thing applies when we look at ECS Elastic Beanstalk, and Lightsail. So Lightsail is, I have a little website that I want to run that runs on WordPress. They put a whole bunch of wrappers and smooth that out. Elastic Beanstalk is I have more of like a corporate application that I need running. And then ECS is I have containers that I need to run. All of these things are based on EC2. They literally leverage EC2, and you pay EC2 prices for a bunch of this stuff, with the exception being Lightsail. And that moves you forward with your compute. So they put wrappers around it to streamline that experience for you, and that helps out a huge amount. But now we get into the really interesting things, and we look at Fargate. Now, Fargate's referred to as a number of things, serverless containers, which drives me insane as a reference point. But the concept is there. Is unlike ECS, where you're running a bunch of servers and instances to run your containers, Fargate, you're just running containers. So you've configured these containers. They contain a lot more weight than a function, but they are a huge amount of value for very little effort on your part. And then we add in the final one, and we get to Lambda, and Lambda is the least amount of effort on your part for a huge return, right? So you want to be more over to the right. You want to try for Lambda, you want to try for Fargate, because you're going to see the most amount of value. That ratio works in your favor because of the little amounts of effort that you have to put forward to take advantage of these services. So last thing in slides that I wanted to show you is really it boils down to this. And yes, there are a bunch of arrows already. Instances, containers, and functions, or serverless compute. EC2 is where your bread and butter is with the instances. It's where people are most comfortable, most familiar. Containers, mainly Fargate, but ECS plays there as well. You can see ECS, I kind of slid down from the instances because conceptually, most people think of it as containers. And then for functions or serverless compute, you want Lambda. But again, Fargate kind of falls into the serverless piece because you don't have to worry about the infrastructure that you're running on it. Add that out a little bit more. All the others kind of fit into the instance level. But really what it comes down to is, how do you pick? Right? How do you choose which one you want? Well, that's actually very simple. If you're starting fresh, assuming you're starting fresh, you don't have anything in place right now, Lambda. You want to build your applications in a serverless architecture pattern, which means Lambda is going to be your compute layer. It is the most effective. It is by far the lowest cost in vast majority of cases because it is truly event-driven. A user makes a request, something executes in the background. If a user doesn't make a request, nothing executes. Your costs stay very low. Your operational overhead stays very low. Your security concerns are very minimal. If you can't make it work in a Lambda, you want to go to a container, and ideally that container is deployed by AWS Fargate, so you don't have to worry about the infrastructure underneath. If you have more customizations required with your containers, or you're deploying a group of containers to build one application, that's when you go to ECS, and you're probably going to end up with Kubernetes, because we can't get through a video without saying Kubernetes. Kubernetes in place to manage containers at scale. Kubernetes is only about managing containers and keeping track of them. So if you have a bunch of them, that's when it's useful. If you only have a few of them, don't worry about that. You can use the native tools in Fargate to pull that off. So for containers, you want to stay in Fargate. If you have to, fall back to ECS. And again, because you're taking on more work. That's why I say if you have to. And then finally, you get to the traditional designs are going to fit into Amazon EC2, because that's really where most of those designs get forklifted over because they can run the exact same kind of hardware or kind of software configuration, because they are literally sitting in the same environment. So very simple. But that's how you choose. You start at Lambda, go to Fargate, ECS if you have to for containers, and then into EC2, because that's where you want to be pushing with modernized applications. That's the real benefit here, is getting to that point where you can get the maximum amount of value out of your efforts in building compute in the AWS Cloud. So what I'm going to do is I'm going to flip over and I'm going to show you a couple of these services, because the idea here is that we really kind of go hands-on a lot when we can. Let me just arrange some windows. And let's jump into the management console. So I'm here with my management console. Yeah, that looks pretty solid. I'll move that up. I'm just trying to make sure that I can actually see the stream to make sure if there's any issues that I can jump on it. So we've got our management console. If you haven't seen EC2, let me walk you through making a virtual machine or an instance. Very, very simple. You can click the big blue launch instance button. This is going to take you to your first choice, which is what is the base image or template or AMI that you're looking to launch from. You can see right off the bat we've got Amazon Linux 2. We can go to Amazon Linux 1 if we wanted to, but if I scroll down, you're going to see all your normal sort of expected operating systems. Red Hat, SUSE, Ubuntu, Windows Server 2019, and then you get into some customized ones. So deep learning on Ubuntu, deep learning on Amazon Linux. These are pre-configured with a bunch of extra software on top of the operating system that make life easier for you. So you can see for deep learning, we have a ton of things that you may not be familiar with if you've never played around with deep learning or AI research, but trust me, the amount of configuration required to set these things up is ridiculous. Having this fully just like one click away makes life much, much easier. But if we want to launch a Linux instance, we just simply select Amazon Linux 2. We'll keep it 64-bit. x86 is standard. ARM is mobile chipset, so there's a whole bunch of software compatibility challenges there, but useful to know if you need it. So we just click the blue select, and now we get into our instance size. Each of these are going to be different choices, different prices. And I just saw a fantastic question from Ashley in the stream about Kali Linux. So Kali Linux is a great distribution for security work. And what you can do is you can find that either in the marketplace or the community AMI section. So let me just go back one for a second. So if I click on previous, I can search for so I search for Kali. And you'll see I've got one in the marketplace, which can be paid for or free, and 13 in the community. So if I click on the marketplace, you'll see Kali Linux is actually set up here, free tool. This is managed by Kali Linux themselves, so these are normally the best ones. And you'll see it's actually $0 per hour for software, plus my normal EC2 instance fees. So this is a professionally managed image as opposed to a community managed best effort one. So if I want Kali Linux, I can actually just select Kali Linux, and it's going to tell me, wait a minute, there's different configurations for this. So I can just say, yes, I want to continue with Kali Linux. And it's going to tell me the prices for EC2. So very, very simple. We can do that by default. Same with any other customized distributions you're looking for. You can normally find them in the marketplace or community. Again, look at the pricing in marketplace. That's absolutely key. But for open source stuff like Kali, there's normally zero charges on top of the normal EC2 instances. So for people who sell software through the marketplace, you can charge something on top of the normal AWS fees. So that's what you need to be aware of. Community ones are always free. Marketplace could be free. Double check the pricing there. But yeah, really simple. Just fire off a search in the search box here and you'll find a lot of really great customized AMIs. In our case, we'll go back to the default Amazon Linux. Click select, and now we need to pick the size. So you'll see here it's in a really kind of handy table. They tell you the general purpose, the actual type. Sorry about all the pop-ups. The web UI is crazy. Number of CPUs, number of memory, storage type, network performance ballpark, whether or not you can get EBS, so elastic block store volumes on the back of it. So you can see basically they just get bigger and bigger and bigger as you scroll down. My favorite, watch out for your pocket, are the big ones. So 96 CPUs, 384 gigs of RAM, 4 900 or 900 gig SSDs, right? Like the M5 DN24X large. There's monstrous compute images in here. You're billed by the minute for EC2. And this is generally with AWS. You want to make sure you understand what you're billed by for each of these because you don't want to spend more than you have to, but you also don't want to sacrifice performance. So sometimes you get in these scenarios where if you're trying to cut corners and save on costs, you're actually going to cost yourself more money because your task is going to take longer. So if I say, well, you know what, I can squeak this out in half a gig of RAM, but it's going to take me 20 minutes to finish my job, versus if I did it in a gig of RAM, it's going to take 5 minutes. It's actually cheaper to go to a gig of RAM, to go up a size, to get that job done faster, to reduce my overall cost. So once you figure out what you want, you simply select it and then go to the next, which is configure the instance details. A lot of this stuff won't make sense for you right now unless you're used to AWS and building out instances. Instances need to go somewhere. This is why we said, push into Fargate, push into Lambda, because you don't have to worry about where they go. With instances, they need to sit in a network somewhere. So all this screen is setting up, how many do you want to launch? You can launch a bunch of them at a time. You don't have to launch just one, so you can launch 20 identical instances or 100. Spot instances mean they can be terminated at any time, but they cost much less. So if you have a job that's failure tolerant, you can do this. So in batch, it's a really good idea because batch will automatically just spin up a new instance. You can save a ton of money. Then this network subnet and auto-assigned public IP is for where it's sitting in your VPCs. Same with placement group. IAM role gives its permissions, so you don't have to give it credentials. IAM roles take care of the credentials. And then some options around monitoring and tenancy and stuff like that. So just some basic stuff. You'll get more and more familiar with it as you play around with EC2 and as you get more familiar with it. For us, we'll just click next to go to add storage. You can customize how much you want. You can pick whether you want slower or faster. You can give it more storage. You can give it guaranteed IOPS, and then you can give it encryption. So based on encryption keys in KMS, really amazing to be able to set that up now. Next, if you go, you get to tags. Tags are super important. There's actually a whole white paper on tags, especially if you have a lot of people using an account. They're just customized keys and values for you to set up, like application, team responsible. Mark's team, right? Team responsible operations, like something like that to keep track of what the purpose of the stuff is, who's paying for it, who's responsible for it. Tags are very, very useful. If you want to set those up, we can. So in this case, what I could just say is name, road to reinvent demo instance. All right, so I just gave it a name, road to reinvent demo instance. Next is configure security group. You can create a new group. This allows traffic in and out, or by default, all traffic's blocked. So you need to explicitly add credentials in here. So if I add a demo, my demo security group only allows people to remotely access. So SSH is the way to Linux to remotely access. You couldn't run a web, like you can't run, or people couldn't access it through normal default ports for web browsing. You need to add that in your security group. Security groups can be changed later on, so this isn't the end of the world, but you really should be launching these locked down so that when you fire up an instance, it is minimally accessible just for security purposes. Then you click review and launch, and you'll see there's some warnings. This is not eligible for free tier. That's okay. And this one, security group demo allows access from the outside world. So, hey, that's bad. You should fix that unless you know what you're doing. You get this summary, and then you're going to click launch. On launch, it's going to ask you one final question, and that is for Linux instances. It says, what key do you want to use to access this? You create a private key and a public key. You keep the private key. AWS has the public key. If I have access to this file, then I can log in. I have to acknowledge it, and then I click launch, and it's going to go. I'll show you what actually happens there. You'll see it gives you a summary. If I click the blue view instances, you're going to see, because I added a name tag, if I can scroll that out, there's my name, road to reinvent demo instance, and it's actually pending. So that was a ton of decisions just to get one server up and running. This is why I said you want to push as far as you can over to deal with Lambda and Fargate. Because as you've seen from our previous streams with Lambda, you just need to literally give it the code and you're off to the races. So if you see all that stuff, so now our instance is actually running. So we could log in if we wanted to, but we're running tight on time here. So what I want to show you is the difference all the way to the other side. If I go to Lambda, when we create a new function for Lambda, I can author it from scratch or I can create a blueprint, right? We've already covered this in depth, so I'm not going to go all the way. But if you simply, let me actually even make this easier. I'm going to show you the existing one we made last time. For creating my Lambda, you just have to add a trigger if you want one and an output, and then you add your code and you hit save. That's it, I'm done. So you just watched, we went through 5 minutes of configuration on EC2 to get a server up and running. Lambda, it's going to take about 15 seconds to get to the point where you can paste in your code or you can start writing code. That fundamentally is why I said that you should start, and let me just flip back to my slides to make the point. That fundamentally is why you should be doing this. Why you should be starting at Lambda, going to Fargate for containers, and then to EC2 as your last resort. Just amount of work. Simply put, the cloud is all about amplifying. The cloud is all about getting you ahead, getting more value, and stop building IT for IT's sake or building all these IT infrastructure layers to get to the point where you deliver value. So when you're looking at servers or when you're looking at compute, you have a ton of options, right? You want to start with Lambda though, go to Fargate if you have to, go to ECS if you have to, then finally down to EC2. Because when you look at this as a layout for compute options, there's a lot of flexibility here, which is fantastic. You can, any move into the AWS Cloud is going to come with a bunch of benefits. The goal here is to maximize those benefits. So the further over to the right towards Lambda and Fargate you can get, the better off you're going to be. So that was a quick overview of AWS Compute Services. I really appreciate you guys joining me this morning. I know it's hard when I'm not on regularly. Like I said, last week I was kicking off that new series for Trend, and I was at the Fast Company Innovation Festival, which was very, very cool. That was the place where Kanye announced his new weird algae foam made in the U.S. Sneakers. It was a great festival. It was very different for me. Not normally at non-technical festivals, let alone at non-security festivals. So that was interesting. But I'll be back on. We've got 18 days before reInvent kicks off, which is absolutely insane, and I'm kind of starting to panic. But I'm hoping to do a couple more of these before we get onto the ground. If you're at reInvent, please, by all means, hit me up. Let me know on Twitter at MarkNCA. Here on LinkedIn. I'll be streaming live under the Twitter handle as well as my own from reInvent. I'll be super active on Twitter during the week as well. Lots going on. I appreciate you taking the time today. Thank you for the great comments. Keep them coming. And we'll see you on the next stream. Thanks a lot. Take care.